Okay, so this is the test infra recap or guidance from Jacob. How the currently how currently the KubeADM job is working, and what we can do to make it even better, and so forth.
Now you're putting words in my mouth, but sure. This is at least a recap of how things work today. A lot of people have asked for this, and yeah, I'll go over the different layers. And hopefully a lot of this will be interactive. I'll be jumping around a lot. It's not terribly straightforward. Apologies. I take very little blame for it, but yeah, do we want to just jump into it? Can everyone who's on the call access the link from the calendar invite? It's very short. It's a Google Doc, and it has a little bit of context about the meeting. But more importantly, there's a new link in it called Layers that I threw in there that should be publicly readable and editable.
Even though you're a Googler?
Yeah, so I created it with my personal accounts.
Ah.
I jumped through many hoops, so hopefully it works. Let me know if it doesn't.
Yeah.
Hopefully it does.
Cool.
Awesome. And I'll also be, oh, thanks, yeah, smart idea. I'll also be sharing my screen, so we'll walk through it as well. Let me do that now. Cool, can you guys see that?
Yep.
Locally. Okay, so first I just wanted to dispel a few myths. I keep hearing these things about our end-to-end test infrastructure that only Googlers have the permissions to set up end-to-end tests, or it's a Googler responsibility to set up end-to-end tests, or that they're completely divorced from the normal implementation workflow, that you add new features and then later on someone adds new end-to-end tests for them. I'd really like to dispel some of those myths. I do know that it is difficult to ramp up on pretty much everything in this repository, this test infra repository, which is why I want to do as much as I can to share the knowledge and help spread the burden, so to speak. But everything in the test infra is completely open source, except for one thing. I mean, the test infra repository itself is open source, so anyone can view it, contribute to it, accept patches. There is a tool called TestGrid that you've probably seen, where the code is internal to Google, but the configuration is completely open source. So it shouldn't really limit you. But that does kind of suck, and I don't think that we're actually trying to protect IP there. I think it's just a matter of demand and effort, and I think there's little demand and it's high effort to actually make it open source. And unfortunately, most of our end-to-end tests, probably all of them that I know about, do cost some money to run because we're actually spinning up VMs in a cloud provider. A lot of them run in GCE, so Google just fronts the bill. So that's great for Googlers because I don't have to worry about those costs. But if you are trying to run end-to-end tests in the way that we run them on a regular basis, it might cost some money. I don't know if we have an agreement to provide GCP projects to other collaborators to let them use it and bill it to Google. I'm not sure. So that does, it's unfortunate, but the entire rest of the tooling, there are ways of simulating runs locally. Hopefully you don't think that this is like a closed proprietary part of the project. It is open to all. Any questions on that before I move on? Cool. Okay.
Well,
so,
one thing we could note maybe is that like the submit queue and some of the logs dashboards, I think, is still like visible only inside of Google, right? That controls test infra, or
what's visible only by Googlers?
So I thought like the submit queue and the pro cluster that actually runs there, is it only? I mean, it's a Kubernetes cluster, right?
Oh, I see what you mean. So the code for it is open source. We do run that code on an instance of GKE that's administrated by Googlers. We might have some other people, maybe Quentin could speak to that because he's on the Engprod team. We might have some other people from the community who do have permissions to edit the cluster or directly access the cluster. But the code is open source and the artifacts are open to be read by all. But like you couldn't go directly to our Kubernetes cluster and start poking at it. But you could edit the code or see job logs. Did that answer your question?
Yeah, cool.
Yeah, I'm browsing as guest right now just because I don't want like email and calendar notifications to pop up, and I'm able to read this perfectly fine. Cool. So there are a lot of layers in the test infra, and they're changing all the time. So as soon as this recording is done, I'm sure this will be completely obsolete, which is what makes it also difficult to write a document about this. But I think it would be useful to first talk about kind of two different molecules of this. And one is everything from prow down to kube test as one giant molecule, and then Kubernetes anywhere and downward as another molecule. And we'll dive into those. And I should also mention, I scheduled this for an hour. This might be the first session of many. I don't know how long it's going to take to cover all this. So we'll see. If we run out of time, we'll just schedule a follow-up. So based on the Google spreadsheet I sent out before, it sounds like there's this interest in learning about JSON and Terraform, but most people want to learn about Kubernetes Anywhere. So Kubernetes Anywhere is a project that existed prior to these end-to-end tests, and it is it's based off of JSON and Terraform to be able to bring up a Kubernetes cluster. And prior to our end-to-end test, it had no support for kubeadmin. I added support for kubeadmin as a path of least resistance to be able to get our end-to-end test working. So I'm assuming everyone here is familiar with kubeadmin. It has no concept of provisioning infrastructure. It just assumes once I'm running on a host, then I know how to initialize a kubeadmin cluster, but it doesn't bring up VMs or anything. And so an important part of our end-to-end test is that we want to bring up a fresh, never before touched cluster in a cloud provider to run end-to-end tests against it and then tear it back down. And we want it to be fresh every time so that we don't have artifacts left over from previous runs that influence the way future runs work. And so kubeadmin didn't have any support for give me a brand new cluster. So Kubernetes Anywhere had this concept of, it's actually a 3-phase thing. Are people generally somewhat familiar with what it does? So provisioning your cluster comes in 3 phases. The first phase is like the raw infrastructure. I need some VMs, I need firewall rules. This is very specific to your cloud provider. Phase 2 is now that I have those resources, how do I actually install Kubernetes on them and get configured? And then phase 3 is add-ons. So phase 1, you're generally working with the cloud providers. At phase 2, you still need to know about the cloud providers a little bit to know how to install Kubernetes. But it's generally, for our use case, it's generally just calling kubeadmin init or join. And then phase 3, all you need is a kubeconfig file because add-ons, you can use kubectl and point it at a master to apply add-ons. There's a bit of a README here. And so the way this works, and I'll do a quick demo, which I have a little bromance still left over for. Are people able to see my terminal now that it's in a different window? Okay, cool. Okay, so this is Kubernetes Anywhere.
I can't see it.
Oh, you can't see it? Maybe if I go on full screen. Maximize. Does it break because I'm going full screen, or can you see that?
I guess it broke because I was not going full screen.
Okay, but people can see the terminal now? So let's talk about Kubernetes Anywhere. So the main interface for Kubernetes Anywhere for defining your configuration is a .config file that looks like this. When you first check it out, there's nothing there, so you have to build this up. And in order to configure this, we use a tool called kconfig, which if you've ever developed the Linux kernel or tried to compile the kernel yourself, you're probably familiar with like make menu config or make config. we're using literally the same tool to build this up. But we define the 3 different phases independently. There's a bunch of variables you can set. Boolean flags take a Y or an N. Everything else is pretty much a string. And this completely defines how you want Kubernetes Anywhere to build your cluster. And then the way you actually perform actions, instead of having a binary or other Go code, is makefile targets. I didn't make these decisions. The project existed before me. But you can read through the makefile and see that we have different targets like deploy cluster, destroy cluster, and those are pretty self-explanatory. There are also some intermediary steps, which I'll show, but we also have these dependencies on JSON and Terraform. So if you actually try to use the makefile and run make targets just in your normal shell, you're probably missing a lot of dependencies. So there's this convenience target that's it's called make Docker dev, and it builds a Docker image that has all of the dependencies you need and drops you in a shell with the current working directory mounted up under opt Kubernetes Anywhere, so that any changes you make are actually reflected in your parent environment. So if I do make Docker dev and I'm in the shell, I can actually type make menu config. And so this would look very familiar if you've ever tried to configure the Linux kernel.
Question?
Yeah.
Earlier, does this thing support multiple masters?
Right now it doesn't, but it should be. So Kubeadmin doesn't really support multiple masters right now either. But once we support HA mode, then it should be easy enough to model here.
Thank you.
So what kconfig gives us is we can define configuration, and I'll actually show you really quickly. So each phase has its own kconfig file that describes the parameters that it wants set. And so you have these blocks that say, hey, I have something called number of nodes. It has a default, it has a range, a little description. And then it has some basic if then else logic, so that you can even say things like, let me go back into it. So in my phase 3, deploying add-ons, if I don't want to run the add-on manager, then there's no reason to ask me about specific add-ons to run. So there's a little bit of like submenu support and things like that. So right now I have it set up to just provision 3 nodes. My cloud provider is GCE. I have my project set up, my GCP project. And phase 2 is where I've specifically said I want to use Kubeadmin. You can specify the version of Kubeadmin that you want to use, and I'll talk in a minute about how this string gets used, and the version of Kubernetes you want to install, which is independent of the version of Kubeadmin that you're using, and then what add-ons you want to run. And then after this, you have your .config file. And so the rest of Kubernetes Anywhere, as I said, is based on JSON and Terraform. And so at a very high level, Terraform takes configuration files that describe your cloud infrastructure and allows you to say Terraform apply, here's my configuration. If you're starting from 0 and you have no resources created, it will create all of those resources. And if you already have those resources and you change your configuration file and say Terraform apply, it will reconcile the changes in your configuration against your current, the current state of your overall infrastructure. I think I see comments coming in, maybe. If anyone's actually reading those, please shout them out. I don't have a good view to see everything all at once. But Terraform's configuration is static in that I don't believe that it supports much like templating. So in order to address that, because we do want to have a general definition of what a GCE cluster looks like, a general definition of what an Azure cluster looks like, and then just fill in some variables, that's where JSON comes in. So JSON takes these, let's see, here's an example. So for GCE, which I'm most familiar with, sorry to the other cloud providers, although there are other examples there, we have this GCE.JSON. And JSON has definitions for how to write functions, how to deal with different scopes. You can pass arguments around. You can do parameter substitution. So we can generically describe what a cluster looks like, but then plug in specifics based on your configuration. And then when we run JSON it against this, you can see this kind of looks JSON-ish. I think it's actually a superset of JSON. The output of that step is going to be a full JSON file that is completely specified. So let's see. So I'm just going to run make deploy cluster. And you'll see it's, we generate a token for kubadmin. It ran JSON it to output the configuration that we then feed into Terraform. And now Terraform is creating all of these resources and bringing up my cluster. And while that's happening, I'll show you a little bit behind the scenes. So
you're auto-generating the elements that beforehand, before you even create the nodes, because you can't swizzle, as Joe likes to say, with Terraform.
Yeah, so you'll see there's this awesomely named do script that just says do a thing. And we generate the token on the client side and then feed it into both kubadmin init and kubadmin join.
And that just means that, okay, so then it's automatically pre-configured before you even run. So instead of you passing things around and doing it in order as you would on the command line, it's prepped before.
Yeah, yeah. And that's just because, I mean, it is kind of a difficult thing to do when you're trying to automate this and start up a VM and then capture the output of a running command and then use that as the input to another command. Yeah, so we actually don't have end-to-end coverage for that kind of scenario. This was just easy enough to put together. But if anyone has ideas of how to script that, feel free. We can have other ways of initializing. We also always do normal discovery instead of file-based discovery or HTTPS discovery. So at the end-to-end test level, that's untested right now. Okay, so here we go. So this is done. I have a kubadmin cluster. I have an output. Terraform allows you to specify these are things that are important to output after you're done. So our master IP is pretty important. But you can also see some intermediary artifacts. So even though we were working with this flat .config file where you can see periods are used as a delimiter between basically the different menu levels, we actually want to feed in something that looks like this into JSON it. So there's a little utility that converts between the two because JSON it wants JSON input, so it just follows the same semantics and turns this into a structure and substructures. You can also see if I go into my phase one into GCE, there's a .temp directory, and you can see what my full Terraform configuration looked like. This was the output of JSON it. And you can see this is a lot more verbose. I'm going through page by page, a lot more difficult to read and manage and configure versus the level of abstraction that this gives you, which is one of the goals of Kubernetes Anywhere, was to make it easy to set up and accurate to provision. So it should be reproducible, but the configuration should be concise. But if you really want to, you should be able to dig into those other artifacts to see exactly what's happening. So this is the basis of that inner layer of our end-to-end test, which is I want to test kubadmin, but I need a fresh cluster in some cloud provider to actually initialize kubadmin so that I can run end-to-end tests against it.
Go
for it.
Yeah, so two questions.
Yeah.
The first one is, it seems like kubadmin init is run at phase one level, right, on startup, instead of actually executing on machines after they boot up.
Yes.
Is it right?
So ideally, the different phases would be completely decoupled. And originally, I had it somewhat decoupled. It's a little weird. And that's just because it's easier when you're provisioning a VM to say, here's a startup script, please run it, than to provision the VM and then wait for it to come alive and then send a command against it. But that's something that we're readdressing with the kubeadmin upgrade tests. And so I think we may do some restructuring here to actually decouple these. And I'll show you exactly what I mean. So in phase 1, GCE, here's the configure VM script. And if you're not using kubeadmin, the other implementation for phase 2 is Ignition. And so what we do in this JSON configuration is when we define the startup script, we actually say, well, we're going to import this generic configure VM.sh, and then based on your phase 2 provider, we're also going to append these other subscripts, so either for Ignition or for kubeadmin. And so the generic configure VM script installs Docker and basically just installs and starts Docker. And then if you're installing, or if you're using kubeadmin, what we append to that are steps to specifically fetch the token from the metadata server, figure out what version of kubeadmin we should be using and the version of Kubernetes that we should be installing using it. I'll explain this entire ugly block in minutes. And then if you are the master role, if you're starting up as the master, then we do kubeadmin init. And if you're a node, we do kubeadmin join with other, sorry, go ahead.
Did this all presuppose Debian and everything? It's all hard-coded.
Yeah, so to give you more context, when we wanted to bring kubeadmin to beta, we wanted the minimal amount of effort to get some end-to-end tests running. All of this is set up with generic enough layers that we could easily say, well, now we want end-to-end tests to run against Azure or AWS. And we should be able to swap out the images. But right now, the only fully supported end-to-end workflow is GCE plus kubeadmin using Ubuntu images. I believe Debian images work now, but before, the old, latest, stable Debian image didn't have cgroup set up properly at boot. But yeah, so we should be able to add CentOS or whatever other OS images that we want. Right now, it does expect Debian. Or sorry, Ubuntu.
Yeah.
But so, oh, go ahead.
Yeah, that's right. I mean, that was what we had to do to get it to beta.
Yeah,
and
yeah, there was a lot of, and you'll see why this was difficult to get it to beta, because this was actually the simple part, adding kubeadmin support here. It's all of the layers above it to get it integrated with our test infra to actually be able to run end-to-end tests. But now that everything's in place, we have people that have been adding in. So another assumption is that you're going to use the WeaveNet CNI provider. And so someone else has started work, and I think it's in review. It's pretty close, although I think it's stalled a little bit. Use other CNI providers instead. So if other people are motivated to want to end-to-end test other cloud providers, other OS images, I'm free to offer guidance. I don't have the bandwidth to do it all myself, but I can definitely walk you through the touch points. So when you feed in the Kubernetes version, this comes in from the metadata server, and you can see it's just a parameter to kubeadmin init somewhere over here. Oh yeah, okay, we throw it onto ops, and then ops get added to Kubernetes init if you specify Kubernetes version. We also want to be able to test the default if you don't specify a Kubernetes version, because that's what a lot of people do. And I think based on the version, we'll default to stable 1.7 or stable 1.6 or whatever. Now, the kubeadmin version, this is a little hacky. You can specify, right now you can specify the string stable, which means I want you to use the stable sources. So we add a new apt repository to fetch it from here. I've also been meaning to add an else for unstable, because then we just have Kubernetes Xenial unstable, and then we could set up end-to-end tests that will actually verify when we do a new build and push it to the unstable channel. Right now, we're usually kicking off manual end-to-end tests before we promote it to stable, but it'd be nice to support unstable here. And in that case, we just do apt-get update, apt-get install the components that we need. Otherwise, you can also specify a kubeadmin version that looks like a Google Cloud Storage URL. And this is how we plumb through in our actual end-to-end tests. If you have a pre-submit test, or you're just running a CI test after a commit is run, we upload the artifacts to a pretty long, uniquely qualified URL in Google Cloud Storage. And so if that's the case, you specify that string here. We use the GSUtil to sync down the entire directory to a temporary directory. And then we use dpackage-i for the artifacts that we want. Ignoring failures, because if you just use dpackage directly, it's not going to automatically fetch your dependencies. It'll just say, I tried to install these and I couldn't find, or you don't have these dependencies installed. So then we immediately followed up with a command to fix that and fix the state of our apt packages and install the dependencies you need, and then start kubelet. And then the rest of the flow is the same. Any questions on that layer?
So are we still, I saw that in phase 2 there's ignition, and checked the Git history of that one. It's pretty stale, right?
Yeah. I think now that kubeadmin is supported, people have just stopped caring about ignition. But since I very selfishly only added kubeadmin supports in a very limited scope, just to GCE with Ubuntu images, we can't just immediately deprecate, well, we could deprecate, but not immediately remove ignition, because if you want to deploy with Azure or AWS or any of the other cloud providers, ignition is the only supported mechanism. I also think that ignition is currently broke for 1.6 and 1.7 clusters. So I don't know if anyone's actually using it anyway. I don't know if we have any statistics on that.
Yeah, I mean, what I was thinking about is like, could somebody test it with 1.7 and 1.6? And like, if it's broken, we'll just remove it. And if we do that, we can also get rid of kubedns and maybe some other that kubeadm automatically deploys add-ons. And we could add the actual phase 2 kubeadmin thing, which will be much more, well, composable. So we could use other OS images. I mean, it could be just an if block, like if OS release is this, then do apt-get install, and if not, like yum install or something. I don't know. Worth mentioning is probably that the GS URL is coming from like Bazel deb builds. So we have another like duplication thing there where we have actual release debs and we have duplicated Bazel debs coming from CI.
Yeah, so I'll talk about the way those jobs get orchestrated a little later, but you're right. So so this presupposes that we're using the debs that were generated by the Bazel CI job. And in case anyone else didn't follow, so when we do official releases, we actually have different logic. Like this is the well-supported path is we have the release repository, go Kubernetes release. And then within that, we have subdirectories for deb and RPM, Debian and RPM for building these artifacts. And so when we do full releases, we actually run scripts here to build them in one way. And I wouldn't say as an experiment, but there's momentum around building them in another way using Bazel, which is better for a few different reasons, but it doesn't have feature parity, or at least our build targets don't have feature parity with the release scripts right now, so we don't fully trust it. So it's not used for our real releases, but we do use it for our CI testing now, just because it's a bit impractical to use these release scripts during our CI testing. Building all of our Debian images takes something like an hour, which is not fantastic for a pre-submit job that's blocking your PR. But we do have momentum toward moving everything onto Bazel. And I don't know if we'll deprecate a lot of this release stuff. I don't know if we'll deprecate makefile support if everyone's just using Bazel instead. But it's nice that we have our Bazel artifacts in the main repo versioned with the rest of our code. Whereas we actually just had a bug where we made a change, someone made a change to this release repository for kubeadmin.conf for our Debian and RPMs. And since this doesn't get versioned with our code, the change was only supposed to apply to 1.8 clusters, but was accidentally built into 1.7 releases, and that caused a bug. So it's nicer to have those source artifacts closer to the code that depends upon them, using the same release branches and just everything else there. So there's a little digression.
Just to touch on the regression there, at least there again, the debs support versioning with stable, unstable, and nightly, like different branches. But so in this case, we would just have put it in the unstable directory only, not the stable. But this again isn't we don't have feature parity with RPMs again in the release script. So, well, the main thing with Bazel, the main limitation, I think, is cross builds. It doesn't support multiple architectures, right?
Yeah, and up until very recently, we didn't have version stamping working correctly. So we would always, if you queried the version of the API server, it'd always say 0.0.0 instead of actually using the proper build version. I think that's fixed now. And I think Jeff Grafton has basically been playing whack-a-mole with the remaining gaps between our Bazel builds and our Makefile Docker-based builds. But yeah, cross builds are one of the last big things preventing us from using Bazel for full releases. Cool, so that's kind of an overview of the Kubernetes Anywhere layer. And so, as I mentioned, the main interface here is we want to create a config file, and then we want to run Makefile targets, like make deploy cluster or make destroy cluster to bring them up and bring them down. So how we do that in the end-to-end setting, if we jump out one layer, is
one more question.
Sure.
Where do you store the GC service account, and what permissions does it need?
Good question. So when I develop locally on my desktop and I set up my account.json, you'll actually see if I do get status ignored, I think we ignore it by default. There's some temporary files, there's some state. When you want to set up the service account you use for GCE, you have to create a service account and store it in this, it assumes that you name this file exactly account.json. I use a personal development project that happens to be billed to Google, but I set it up. It's not like a shared thing. When our end-to-end tests run, we have these notions of a pool of projects that get used, and they're all owned by Google right now. And the way the plumbing works is, I think it gets set as an environment variable by prow, so that our job can reference it. And I'll show how that actually becomes account.json. But that is something like you could absolutely set up a GCP project and just create a service account. And when you set up your configuration, you specify the project here. So you can see this is Beecham, that's my personal project. But Google's projects, I don't know if I'm actually answering your question, but Google's projects are plumbed through a different way, and they're managed by a different pool service called, previously our end-to-end test had a hard-coded product that they should use, and they knew how to get the service account because Prow does magic with it. We're actually moving to a model where they call a service that runs on the same GKE cluster called Boscos, and they ask for a project and use that instead, because we've had quota issues and just a lot of bad things happening when we were using these static projects.
Yeah, for what it's worth, all Kubernetes jobs are now broken at head because of
They're
this.
broken right now?
Yeah, all of them.
Was migrating to Boscos?
Yeah, migrating to Boscos. Somehow. I have the issue somewhere there. It's just one or two lines away from someone. But yeah, it's this grand migration.
Sorry, one question. How kubeadmin detect that the node are ready before installing the add-ons?
Oh, yeah, good point. So if you look at the makefile target, if you do deploy, it does a deploy cluster. This is actually just a phony target that depends on deploy cluster, which is the phase 1 bring up. It runs a separate script for validation, and then it runs add-ons. So if we look at the definition of the validate, it uses, first of all, it sets the kube config correctly, and then runs util/validate. So there's this little utility that's just a spin loop that constantly asks for how many nodes you have and waits until it matches the number of nodes that we expect, grepping out to make sure that they're actually ready. Although I think the way this is written also happens to match not ready. So it's just, I don't know if this actually helps anything, but.
Because I did a little bit testing some time ago, and I was stuck here because nodes become ready only after installing add-ons and networking.
Interesting. One of the things that I completely glossed over because I wanted to get to other things, but I'll mention, if you are actually trying to run end-to-end tests, there's another flag that you'll probably want to use. So when you do make deploy cluster, it won't actually validate that your cluster came up and it can communicate with it via kubectl. It just relies on Terraform exiting successfully, so it believes everything should work. The old ignition-based phase 2 was actually able to construct your kubeconfig file locally on the client side with the credentials you needed to talk to the master. Excuse me. So after JSONet and Terraform ran, you had a kubeconfig file locally that was completely valid because it was generating the certs using JSONet or some combination of JSONet and Terraform and stored them locally. When you use kubeadmin, even though we're feeding in that initial token to use so that the nodes are able to join it, the certificates that we need and the full kubeconfig file that we need is generated on the master and stays on the master unless you specifically request that it gets pulled back. So I'll show you what that looks like. I mentioned this do script. So when you do a deploy, if you pass in, or if you set this environment variable that I want to wait for kubeconfig, and again, this is optional because you might be in an environment where you bring up a cluster that is air-gapped. Maybe you don't necessarily want to be able to talk to it. It's just running something automated. Or if you're using the phase 2 provider of Ignition, you don't even need this. But if you set this environment variable, then it runs this fetch kubeconfig, which knows how to SSH to the machine and actually grab this kubeconfig file from disk in this horribly ugly long command where we can't log in as root, but only root has permission to the file. So we, instead of doing SCP, we actually do sudo cat this file and then capture it. But this will actually bring back the kubeconfig file, the correct kubeconfig file that's able to communicate with the master. So if you didn't set this, likely your validation failed because it was just using the wrong kubeconfig. And it was probably being denied instead of not finding the nodes. And it was just hidden in the output of that utility script.
So one thing we could do, I think we definitely should get rid of that logic. Like we could just execute kubeadm like phase certs and kubeadm phase kubeconfig, and then CPO everything with Terraform, and it would work just fine. So I think that's the next step here as well.
Yeah, and we test one end-to-end flow very well, but like I said before, there are many other branching workflows that we want to do. Like Tim mentioned, instead of feeding it the token, our instructions usually tell people to just view kubeadmin init and copy paste the token when you're doing join. I'd love to test both cases. So yeah, breaking these things out so they're more composable so that we can more easily test all the different scenarios would be fantastic. But I also have a desire to have less reliance on our end-to-end tests just because they're flaky and cost money to run and they're constantly breaking. So I would actually love a stronger integration test framework, but I have a different doc for that that's not ready yet. So I'll table that for now. Okay, any more questions about Kubernetes?
Only one last question from me.
Yeah.
I'm understood well that Kubernetes Anywhere now only invokes kubeadmin at the startup phase, so init or join.
Yeah.
And then for instance, is not capable now to invoke upgrade. Okay. Thank you.
Yeah. If I recognize your username correctly, I think you had a doc about different ways potentially to support upgrade tests.
Yeah, yes. I worked to the document. I was only checking that my assumptions were right.
Yeah. No. Nice to meet you. I remember the doc, and yeah, I think Jess might be on the call. So someone else at Google is also trying to plumb through everything that we need to support upgrade testing as well. You two should talk and keep in touch. But I suspect a large part of her efforts are going to be around refactoring things to make them more composable, to make it not that phase one is tied intimately to phase two, tied intimately to the way we invoke kubeadmin, but allow you to send arbitrary commands to a cluster, or at the very least, since Kubernetes Anywhere is a lifecycle project, like it brings up and destroys clusters, it has no concept of upgrades. You can do scaling by rewriting or editing your .config file to change the number of nodes and then do another deploy, and Terraform will scale it up or down. But upgrading is another really important lifecycle event that it has no concept of now. So in order to support that, for our end-to-end test, we want to do end-to-end tests of kubeadmin upgrades. I think it makes sense to add upgrades to Kubernetes Anywhere, the product. Cool. So we have about 15 minutes left, and we've covered maybe like 5% of the material. So I anticipate follow-on sessions for everything else above this, but I'll try to go through enough to be useful, I think. So Kubernetes Anywhere, like I mentioned, like you create a .config file and you run makefile targets to do useful things. The layer above that that's actually integrated with our test stack is called kubetest. And if you have ever tried to run end-to-end tests before, especially maybe a few months ago, you probably saw a command that was something like go run e2e hack.go. That command is deprecated, and this file is now just a thin wrapper around kubetest. Obviously, this is not a fantastic interface to use. It means all of your code has to be in one file. It's hard to write unit tests for it. So kubetest is the replacement for e2e/hack.go. And it is the main entry point for bringing up a cluster, bringing down a cluster, and running our Ginkgo end-to-end test against the cluster. So let me pull that up. And so now it's many more files that are a little better factored than it was when it was one giant monolith. So when you run kubetest, the main flags you're going to have are up, down, and test, and some Ginkgo parameters. And up means I want you to provision a brand new cluster. Let me actually go to the flags. There's a lot of flags. So up means provision a cluster, down means tear down my cluster, and test means run some set of our end-to-end test against it. And our automated tests do up, test, and down. But if you were testing locally, you might want to bring up the cluster once and then do multiple iterations of end-to-end tests against it before you bring it down, just to save yourself time, which is why these are separated. But there's this concept of a deployer or deployment. And this is how we abstract away how to initialize your cluster. So before this interface existed, it just assumed you were always deploying with kubeup.sh. But there are many more options now. So this interface lets you specify the implementation for it. Instead of calling kubeup, we just call it bash. But you can also specify, I want to bring up a GKE cluster, a COPS cluster, or now a Kubernetes Anywhere cluster. So our end-to-end jobs use Kubernetes Anywhere with some configuration. And the implementation of that deployment is in anywhere.go. And so if we look at this, you can see the flags that are specific to this. We have to know where Kubernetes Anywhere is because it has our makefile and our Terraform and JSON templates and all of that. So it assumes that you have already checked out Kubernetes Anywhere somewhere and you give it a path. The phase 2 provider you want to use. So the default is Ignition because Ignition is what pre-existed kubeadmin support, but you can set this to kubeadmin. And then just the same parameters I showed you in the config file, like what version of kubeadmin do you want to use, what version of Kubernetes do you want to use. You can also optionally give it a cluster name and a timeout, which is pretty useful. And you'll see this Go template is basically writing that .config file that we want using the command line parameters. So some of these are hard-coded. We can always plumb in more flags and change these to parameters to substitute. So like all of our end-to-end tests use 4 nodes. They all currently use GCE, but if you want to add support for something else, just add a new flag and plumb it through to where we execute this template. And then if you look at how do we deploy, maybe it's called up. Yeah, so when we, our implementation of bringing a cluster up is this, exactly what I showed you manually, is we just run this deploy targets. Deploy is actually a superset of deploy cluster that goes through all 3 phases. And we make sure that we pass this environment variable so that we wait for the kubeconfig to be pulled back. And that's kind of it, although we have our own separate validation to wait and make sure that the number of nodes matches what we expect. And similarly, when we bring down a cluster, well, first we find the kubeconfig path, but we call destroy, and we pass through this other option that automates. If you actually just do make destroy manually, it'll prompt you and say, are you absolutely sure you want to bring down this cluster? And there's an environment variable, just disable that and make it completely automated. But so, oh, go ahead.
Yeah, one question about, like, you said that the validation is going on like on the kube test level as well. So is there any specific reason we still have some validation bash script in Kubernetes Anywhere, or can we just?
So Kubernetes Anywhere existed as a product before we wanted the end-to-end tests, and I don't know how popular of a project it is now that there are so many more tools to bring up clusters. I don't know if anyone uses it for production or if anyone really uses it to play around with, if there are other options like COPS. But as much as possible, I've tried to utilize it as a tool to allow us to do end-to-end tests without completely distorting it and making it only for our end-to-end tests, if that makes sense. So as a product, it makes sense to independently want to verify that your cluster came up correctly. And I actually think it's kind of a bug that I have more validation here. I think this was before, I think originally I was just running phase 1 and 2 and I didn't rely on the validation, so I wanted to do the validation here. I can't really remember, but this, we can probably safely remove this and depend on its validation.
Yeah, so I was just thinking, if we remove like Ignition, if we test it, it's broken and we can remove it, and then split out kubeadm to phase 2 and remove the obsolete add-ons, we should then be able to get rid of validate. I mean, we should be able to convert it into something that actually works and actually is shaped for, or, well, good to utilize for ETE tests, other than just being a project lying around without having anyone use it, or because it's like broken.
Yeah, so I don't know how many people use it for its original intended purpose versus, I'm sure it gets a lot of use now just in our automated end-to-end tests. I've tried to not step on toes and overly pervert the code base just for my purposes, which was setting up end-to-end tests. But we can make an issue in the repository and say, hey, this seems to be the new direction. Ignition has been broken for 2 major releases. Here's the timeline where if no one fixes it, we're just going to tear out support for Ignition and make everything work much more seamlessly out of the box.
Yeah, I mean, that's what I would propose, like as an outcome of this, is to at least like ask the people, if there's no response or a positive response to remove, we'll just go ahead and do it.
Yeah. Cool. So invoking kubetest is how this stuff happens, how we bring up the cluster and we actually invoke Ginkgo. If you've seen our end-to-end tests, actually go very briefly to show what those look like. So end-to-end tests themselves that we run against the cluster live in the Kubernetes repository, and it's in the subdirectory test/e2e. And every test has these kind of tags. And if you've seen what our Ginkgo flags look like, you can opt into or out of different tags. So let me find something that might be.
It's in Lifecycle. We have.
Are you thinking of a particular test to look at?
So yeah, Bootstrap,
Like
for example.
Bootstrap tokens.
Yeah. So there
Sure.
we have the newly added Bootstrap token E3 tests.
Cool. Let's see. Okay, so in the description of the test, not only is there something that's human readable, but you can specify these tags that say, hey, Serial, I don't think this test should be run in parallel because it's just going to have a race condition with itself probably. And it's also disruptive because it's changing states and maybe doesn't clean up that state afterward. We have a lot of end-to-end tests that are marked conformance, which basically mean that if we run all of the conformance tests against a candidate Kubernetes cluster and they all pass, that is, I don't think we officially certify, but we say that's pretty much good enough to tell you that that this is functioning. Whereas there are a lot of end-to-end tests that are targeting a very specific feature that might not be enabled everywhere. They might be targeting a specific cloud provider, which is obviously not applicable everywhere. And so the conformance tests are the bare bones. I want to create some pods, delete the pods, the very basic test that should pass on any cluster that calls itself a Kubernetes cluster. And so most of our end-to-end test suites just run all of our conformance tests. And up until very recently, all of them only ran all of the conformance tests until we had these new tests that were for kubeadmin features like Bootstrap tokens. So someone can opt into these tests by saying, I want to additionally run tests for the feature of Bootstrap tokens or token signer, cleaner, whatever other component.
Anything marked with feature is by default not run. So if you have feature : anything, it will not be run by the default end-to-end tests.
Right.
You have to it has to always be explicit.
Right. And if I look at where our end-to-end tests are defined, you'll see that they do conformance and optionally they opt into these specific features that we want to run. So let me go back to the doc. We only have 4 minutes left. I'm going to briefly describe these so that when I set up follow-up sessions, I'll try to target 1 or 2 layers to see who's interested in what layers, and I'll try to dive in as deeply as I need to there. But just so you have an idea of what they do, if we go all the way to the outermost layer, Prow is our job orchestrator. So it is a way, it has a configuration file to define what all of our end-to-end jobs look like. Not only end-to-end tests, but also any pre-submit tests, which might just be doing our validation scripts, our Bazel run jobs to do Bazel builds and Bazel tests. It allows us to define what those look like. It has some chaining behavior, which Lucas alluded to, because our end-to-end jobs are actually chained off of the outputs of the Bazel run jobs. And Prow is as a product runs on a Kubernetes cluster. We happen to run our instance on GKE, but it should run on any Kubernetes cluster, which is maybe the only dog fooding a lot of us do of our own products. And so that's where we define what the overall job looks like. We have a custom image to get all of the, to have all of the dependencies that we need, like JSON, Terraform, potentially a few other things I can't remember, which differ from the rest of our end-to-end jobs. So there's a generic E2E kubekins image that most end-to-end jobs use, but since we use Kubernetes Anywhere, it has its own dependencies. We have our own custom image. It's linked here to see how it gets built. That invokes bootstrap.py, which, even though it's prefixed with Jenkins, is actually the main entry point for any job that's defined in test infra. Doesn't matter if it's a Jenkins job, a Prow job, an end-to-end test, a Bazel build. The main interface is you give it the name of the job, and then it's able to figure out more configuration for that job and how to actually invoke it. Bootstrap, its responsibilities are also checking out the source repositories that you might be running tests against. So if you're doing a pre-submit pull job, it will know I should check out Kubernetes at this commit, and I should grab these commits from your pull job, and I should do the merge so that all of the other layers underneath it don't have to worry about, how do I do a merge? How do I pull the references from a PR job? Bootstrap just sets all that up for you in a local directory, so you don't have to worry about it. Most of our job configuration is in this special file called job/config.json. You can grep through it for kubeadmin to see what those jobs look like. It specifies what scenario to use and the flags to pass to the scenario. We use the Kubernetes end-to-end scenario. All of the scenarios are written in Python for some reason, so we just say Kubernetes end-to-end, and it just assumes that it's .py in the scenarios directory. And the responsibilities of this layer are, it has some flags that aren't flags of kubetest, but it's mainly a wrapper around kubetest, which is a wrapper around Ginkgo. But you can specify things like, I have a file of environment parameters. So the Kubernetes end-to-end scenario will read that file and actually set them as environment parameters before invoking kubetest. Whereas kubetest doesn't have any concept of that. It just assumes that you've set your environment parameters correctly. That is a very brief overview, and we have 1 minute left. Are there any quick last-minute questions? Otherwise, I'll go through the same thing. Maybe next week at the same time will work for everyone. But I'll figure out what layer to cover next and do a deep dive as a follow-up. Any last-minute questions?
I was telling you. Yeah, go on.
One at a time.
For the installation of X thing, is it only for released tags that you can use this for? I assume this is end-to-end, you can use any arbitrary commits, but can you do that locally as well, such that I could use Kubernetes Anywhere to test my local changes in whichever stage 1 provider?
Yes. There's actually a document, if I can find it. One of my colleagues, Jacob Simpson, different Jacob, put this together of how to do local testing, somewhere here, develop, using all of your local artifacts. So you just do a local build, and you can use Kubernetes Anywhere to bring up your entire cluster. This might be a little dated. It might be a little easier to do, but it's a good capturing of the overall workflow, and you could potentially substitute different steps if there's a newer way to do it.
Looks like it relies on Google Cloud Storage to hold your binary.
Yes, if you want to change that, it's actually really easy. So the only place that knows that it's Google Cloud Storage is this configure VM kubeadmin script, and it just has this branch logic that says, if it looks like Google Cloud Storage, then I know how to pull it down using gsutil. If you wanted to store it in like S3, just put like elif match S3, and then whatever tool you have, AWS S3 copy to do that, and it should be super easy to do. In fact, if you want to commit that upstream so that everyone else can take advantage of it, do it. Awesome. Like I said, I did the least amount of effort to get our end-to-ends running, and there hasn't been a lot of demand for anything else since then.
Sure. Yeah, I opened up an issue a while ago for adding also the potential to add OpenStack support, and I thought this would be one of the things to add. But that would be great if you'd accept PRs for that. For phase 1 support, is adding any arbitrary clouds, is there a special process for that? If I wanted to add OpenStack support, would that be cool?
Yeah, and I should clarify. So I took advantage of Kubernetes Anywhere because of my interest in kubeadmin and testing it. I am not one of the collaborators or maintainers of Kubernetes Anywhere. I've done a lot of pull requests against it, but I can't merge to it. I never pay attention to issues there, just because I'm a consumer of it. I'm not a maintainer of it. So sorry if no one has paid attention to new issues that you might have filed. I would assume that you're good to go. Like the entire purpose of the project is to support more and more implementations of each phase, and just do it, I guess. Yeah. So
no problem.
Cool. We're 3 minutes after. My GitHub might be linked somewhere. If you have more questions, I have the same handle on Slack. I'm Pipe Jacob right here, and I'll be in touch on this issue for the next in the series if there's still demand to learn more about this. I know there's a lot there. Lucas, thanks for recording. Thanks everyone for attending.
Yeah. So one one last question: are we still using your fork, or is that now fixed?
We are technically still using the fork. I promise I'll fix it like this week.
Okay, cool.
Awesome.
So yeah, next week, the same time, everything sounds good to me.
Cool. If there's general agreement, I'll just set it up. If anyone really wants to attend and doesn't want to watch the recording afterward and can't make it, let me know and I'll go through the same annoying like Google Sheets availability sign up thing.
Thank you very much. Bye-bye.
Cool. Yeah, I hope it was useful.
Yeah, really.
Okay.
Thank you.
Yeah.
That was great. Thanks.